Hi everybody. So happy New Year. And I decided I haven't posted a lot on Substack because I'll tell you about why I got stuck. But basically I'm working on a talk that's coming up in February, and I thought as a reward, so as my New Year's resolution is to get up every morning and work on math for a couple of hours. And I really prioritize that. So I want to do that this year, Monday through Friday. So I might work on some other things on the weekends. I have some other things I'm working on involving prime numbers, but I'm not crazy. But so I'm basically like gonna work on my stuff in the morning and then maybe do like a 5 minute, as a reward, like a 5 minute like talk to you guys for a second, and it's fun to post. So I don't know if I'll post a lot or if I'll post too much. If I post too much and people stop subscribing, then I'll cut it down. But I got a lot of subscribers yesterday, like a kind of an influx, but I'm not posting anything for a while. Okay, so why did I get stuck? So I got stuck a little bit, and I'll tell you about my talk in a second here. This is only gonna be a few minutes. I got stuck because I'm writing chapter 4 of the book, and chapter 4 is about large cardinals, and the next large cardinal is strongly compact cardinals, which are kind of hard. They're so important, but they're kind of hard. And then I have to do super compact cardinals and all this stuff. But my talk is about super compact cardinals, so I thought, I'm gonna take a break on the book so I can focus on this. And so I'm just gonna talk about what I did today. And okay, so today, I got stuck on super compact, strongly compact cardinals. Okay, but anyway, so my talk is going to be about degrees of super compact cardinals and then how to softly kill them. Okay, so part of it is it's very similar to measurable cardinals and Mitchell rank for measurable cardinals. This is Mitchell rank for super compact cardinals. Okay, which I defined in my thesis, in the second half of my thesis. So I really need to do a couple things. I need to publish this part of my thesis, which I didn't do yet. Okay. And then also I'm giving a talk. The talk is really helpful because I'm working on this. So the talk is going to be in February, and it's only like 20 minutes. But like I want it to go really well, and it's fun making slides, and I want it to go really well, and I want to like review everything. And okay, so I'm going to show you the slides. Hopefully you can see it there. I'm going to just post it as a split screen. Okay, so I think it's really helpful to just like talk to you guys after I work on this. It's like a reward, and it's also like motivating to like get the slides done. Okay, so the first thing is before I talk about sorry guys, like below my nose. Okay, so before I talk about super compact cardinals in the talk, I'm going to talk about measurable cardinals because it's like I said, it's like pretty similar idea. So the super hard part, by the way, is the proof that you can like softly kill degrees of measurable or degrees of super compact because they're really long. And I'm giving this talk at a philosophy conference. So I want to make like a bigger picture about this. I want like someone that comes to the talk is like, oh, I kind of see how the proofs go for something like this, like a lifting argument and like a destruction/preservation argument. I want someone to see the bigger picture, and I actually am going to try and make pictures of this proofs, like sort of a picture of the proof. Okay, so now you guys can start looking at the slides that I made for today. I don't know if I'm going to actually like. I'm in my apartment, but I have this cool like background. So I don't know if I'm actually going to keep the slides as is, sort of hand drawn like that, or if I'm going to make them more like Beamer slides with the pictures in them. I don't know. If you think that one way looks cooler than the other, let me know. Okay, so I made 3 slides today. It's just about measurable cardinals. So there's like 2 leading roles in this movie. That is the slides for this talk. The talk is just degrees of super compact cardinals, introducing the degrees of super compact cardinals. So the leading role number 1 is measurable cardinals, and this first slide just says an uncountable cardinal is measurable if it's the critical point of a non-trivial embedding J from V to M with M a transitive class. And so you can see the kappa, and he's saying, I fly above the rest, I start trends. Because kappa is the first point that's moved by J, and then after that, all the points are moved. And before that, everything is just mapped to itself in M. I could put on there Ulam 1930. I'm going to stay away from the history on this one. so I get a little worried someone's gonna say, what's an elementary embedding? And like, okay, well, you know, it's like J of V is like an elementary substructure of M, and elementary substructure means that like first order sentences are preserved, and if you use the parameters from the smaller structure, that sentence is still true in the bigger structure. Okay, I maybe need to work on if someone just like a quick answer on that. Okay, so then there's several other definitions. Here's another favorite. There exists a kappa complete non-principal ultrafilter on U. And so it's like kappa is being, so that another way of saying that is we can measure just big or small, the subsets of kappa, where any intersection of less than kappa many big sets is still big. And so I think it's like there's something that's coloring all the subsets of kappa. Okay, then we have both on the same slide. Do I need to do this? No, I don't need to show that these two are equivalent in any way, but I feel like it kind of helps you get into, and we are going to need like to work with ultrafilters, especially with super compact cardinals. We have to work with normal fine measures and stuff. So I do need to like kind of go, having both of these just sort of ready in people's minds will be good. Okay, the talk is 20 minutes. So these slides are going to take like a minute total together, you know. But I'd rather just be totally prepared. Okay, so the two definitions, I'm just going to show that these are sort of a proof-ish that these two are equivalent. And if you start off with it's a critical point of a non-trivial elementary embedding, J from V to M, M is a transitive class. Then U, the set of all X subset of kappa such that kappa is in J of X, that is, I think you say like kappa is like a seed. That is a kappa complete non-principal ultrafilter on kappa. Okay, I'm not gonna prove that, but that's how you get from the elementary embedding to the kappa complete non-principal ultrafilter on kappa. And then the other way I wanted to show, like they have this ultrafilter guy and he's painting things, you know, up or down or big or small. And if you take regular like if you take ultra power embedding of V by U, then that will be assign constants to their equivalence class of repeated themselves according to U. Okay, so I would just put in there like a little advertisement for my story, chapter 3, part 3 of the Set Theory Guide for Artists, which has a creative take on how you form an ultra power embedding, or how do you form an ultra power of the universe, and it's like about these producers of the universe talking. So I would say that. Okay, so we have some idea of there's many definitions of measurable cardinal. Thankfully, I don't have to mention normal right now. Like I could do that later. But here's two that are really, you know, favorites of I think a lot of people, everybody, and why they're sort of how you can go back and forth between. Okay, I didn't show that U is a kappa complete non-principal ultrafilter. I didn't show that this elementary embedding has critical point kappa, but okay, again, these are like going to be 3 minutes. Okay, so that was 8 minutes. That was a little long, but okay, I don't know when I'll see you guys again. Maybe tomorrow. If I'm posting too much, I'll figure that out. And okay, well, I hope you guys have a great day, great New Year, and your New Year's resolutions are going amazingly. And you fucking, you smashed this year, you know, out of the ballpark. All right.